We've been talking today about the new. We've been talking about all of these new developer tools that are getting out there. We even have a new one that we've added to this list, JFrog Fly. Woo. So with all of this, we are seeing the advantages, but others are seeing a way in, a threat. So threat actors, they like the new. When there's new stuff out, there's excitement. People sometimes don't really think about the risks that comes with this. And we are seeing developers constantly, continuously downloading and experimenting with new tools. You guys scan the QR code. We want to try this. We want to see how this progresses us towards achieving our goals. And this is exactly what threat actors are looking at for. They want to tap into that excitement so they can inject malicious payload, and this is continuously happening all the time. We'll talk about a lot of examples today. So maintainers of open source and also developers and enterprises are being targeted because they have the keys to the kingdom. And one other malicious package we saw was this. This was recently discovered, another malicious package in NPM. Why am I telling you about yet another one? Because the same threat actor, we don't know exactly which group it is, but it's a very sophisticated group that added this malicious package to NPM. They've decided to expand. And we've been talking about Visual Studio Extension. And we've discovered, was discovered by the JFrog research team, that they've also expanded into Visual Studio Code extensions. They've added this supposedly benign extension. It uses a regular extension that looks very similar to a legitimate one. They're doing some sort of changes and trying to get developers to use it. And of course, they're using the fad and the excitement around generative AI and coding assistance. So this says that it's ChatGPT. And we've talked about VS Code, but this is not just happening for VS Code. So the community took the VS Code format and have expanded it to other IDEs, so Cursor, Windsurf, all sorts of IDEs are now using this format, and we have, as a community, a new public repository that we should care about, which is OpenVSX. So OpenVSX is now containing a lot of these extensions, and many of the new IDEs, the shiny IDEs, are using that. And we know what happens when there's something new and exciting. The attackers come. So this person, he's a prominent developer of Ethereum smart contracts. He was attacked by a malicious Cursor extension. We'll see what it is, the Solidity one. And this person, who was very careful, as they say, was hacked, and this attack was able to extract almost $500,000 from his blockchain wallet. Now, what happened? So he wanted to install a syntax highlighting extension to Cursor. And that syntax highlighting extension is called Solidity. So we'll see. We have two versions of Solidity here. This one, the one on your left, and this one, the one on your right. And we can see that the differences are not that significant. The text looks the same, the name looks the same, the author's name, Juan Blanco, looks the same, the rating is the same. What I'm seeing here different is the number of downloads. So, who here on the crowd thinks that this is the malicious package? I don't see anyone. Who here thinks that this is the malicious package? Come on, raise your hands. No? A lot of people here are a bit absent. Okay, so most of you raised your hand for this one. Well, I'm afraid you're wrong. This is the malicious package, the malicious extension. And why? Because attackers are smart, and they are able to fake the number of downloads because they can download it on their own. So that's what happened. And we obviously now understand that we cannot just curate our open source packages, our NPM packages, our PyPI packages, our containers. We have to curate, and we have to be aware of our tools, the tools that we're using, and amongst them are developer extensions. And we can trust curation, JFrog's curation, because it works. Our expectation is that by the end of this year, we will reach 50,000 this creates a huge load on developers that have to fix it. Not only that, but the expectations are becoming much, much higher in terms of how much time do we have as an organization to deal with these vulnerabilities. So we have lower SLAs. And it's when we are struggling, all of us are struggling to keep up, given that there are more vulnerabilities and less time to fix them. So what do? So we at JFrog, we really think we need to focus. As an industry, as a community, we cannot solve everything. We need to focus on what matters. And what we think matters are CVEs that are critical, really critical. We'll talk about that. And also CVEs that can be exploited. And finally, CVEs that are actually running in production. These are the things that we should all care about. These are the things that you get a call in the middle of the night for. So we need to focus on that and not just check boxes. And we've researched all of the vulnerabilities that have been released, all of these thousands of vulnerabilities, in order to understand what is really happening. And what we've decided to focus on first is whether they are really critical. Because what we've found is that there are many, many critical vulnerabilities released each year. But 88% of them, we've downgraded their security severity ranking. So JFrog puts severity ranking for each vulnerability, and 88% of them we had to downgrade from critical to lower grades. So really what we're seeing is that we have to deal with a lot of vulnerabilities that are not really critical. This saves us a lot of time. And I'll give you just one example because you might not believe what I'm saying. So the Go package, pretty common package, right? 1 out of 3 of you has it in Artifactory. And 2 years ago, there was a very critical vulnerability, 9.8 CVSS out of 10. Everybody rushed to fix it. If you guys know anything about JFrog, you know we also use Go. We had to go and fix it. And we looked into it. And what we found is that in order to exploit this, it's a vulnerability, mind you, you have to install a malicious package. So it's a vulnerability that in order for an attacker to exploit it, you have to run malicious code. So why would they even exploit it? You're already running malicious code. So this isn't really a vulnerability. It will never happen. So we've downgraded it. And now we all had to go and try to convince our customers that this is really a low severity vulnerability, and there is really no way for someone to exploit it. And it's in Go. It's a very popular package. We have it in many of our images. So this is just one example where if we as an industry can agree on what really is critical, and we can have that information coming from a trusted source, we think we are with JFrog research team, we can understand what is really critical. Each direct dependency comes with their own dependencies, which we call transitive dependencies. Our application uses a handful of direct dependencies in most cases, and those dependencies come with some other dependencies, and usually they outnumber it by some factors. So we usually have more transitive dependencies than we have direct dependencies, which makes this number really logical. So when we looked at this and said, wow, so many vulnerabilities are coming from transitive dependencies that our developers don't even know about in many cases, they don't really care about them, they care about the direct dependencies they chose to use in their application. We wanted to see whether we can tell if these vulnerabilities are actually exploitable. So we looked into it and we wanted to say, look, we have an application, it has a direct library, that library has a transitive library, that transitive library might have a transitive library of its own, this becomes complex. And finally, we want to understand whether there is a direct path between my application, my direct library, its transitive library, and the vulnerable library. And we want to see if we're actually calling the vulnerable code. And this goes to layers. We've just shown here a couple of layers. It goes much deeper than that in complex applications. And what we've done is we've decided to tackle on that problem and really extend our contextual analysis to transitive contextual analysis, so we can tell you this immediately and by pre-calculating all of this, because open source code changes, but it changes with versions. So we can download, we're constantly downloading all versions of software packages out there, and we can pre-calculate this information for you so you don't have to do all of this analysis on your environment. So with that, let me just show you this real quick. What we're seeing here, we're seeing JFrog X-ray and with JFrog Advanced Security. And this is a container that we've scanned. This works both on binary and source code, by the way. And we're seeing a vulnerable app, and we will want to go and look at the vulnerabilities that this app has. So with that, we can see that we have a couple of criticals here. We have some highs, we have some policy violations, and we want to go and see which are they. So we see that we have 2 applicable vulnerabilities, and we want to go and check this one out. This one is in the Braces software package, so we understand that we have a problem. We want to look into that and see where it's coming from. So we go to our software bill of material list, and we start searching for Braces to see how it is, where is it coming from, and we find it, and we see that it's an NPM package, and it's a transitive package. So we can go to our components tree, a new view, that allows us to see really how our application is built, who are the directs, and what kind of transitive they bring with them. So we understand that micromatch is the direct package, and it brings the Braces package, which is vulnerable. We can also see this is happening, this is enabled for Java as well, not just JavaScript. So going back to the vulnerability, we want to understand more details. We want to understand how it is applicable. So we open our tab here, and we can go to contextual analysis and see really what's happening. We see that the micromatch is calling, the match function in micromatch is calling Braces. It's initializing a constructor and calling that vulnerable function. So really we have an application that is calling micromatch, that is calling Braces. And we can see this as a graph here. This is just a very simplified example, but this happens all the time, and it can go as deep as you want. So now we can know whether micromatch is using Braces in a vulnerable way. That's great. How do I fix it? So definitely we can fix the direct dependency, and it will fix the transitive, or we can be more proactive and fix the transitive. Of course, this could come with some issues. Finally, when we look into this, we want to have very actionable information on what we can do and how we should fix. So we can see here recommendations that tells us that if we upgrade 8 components, we will solve 27 vulnerabilities. We are also getting information on each upgrade that is recommended, how many direct vulnerabilities it solves, and how many transitive vulnerabilities it solves. So this is a very good screen to start with to prioritize our fixing. So we've expanded contextual analysis in JFrog Advanced Security to include transitive packages as well, given how prominent they are and how popular they are in the number of results that we get when we scan for our applications. Now the last part, we want to know what is running in production. So we've seen this earlier on the Uptrust session. We've seen JFrog's runtime security. This is a solution that allows you to know where your binaries go. It connects between Artifactory and your production environments. It works on Kubernetes clusters where you deploy your containers. And it can tell you that these containers actually came from Artifactory, that they have not been tampered with, but it can also tell you that they're running and what is their security status, so you can prioritize and know that a certain container is actually running in production, so you should care about it more. So I'll show this in just a bit. What do we have here? We have here the Artifactory, and we're looking at the Docker repo, and what we're seeing here on the screen is information coming from JFrog Runtime Security that tells us that this container is actually running in production, but no one is scanning it. And we should focus on what is running in production, so we want to scan it. And this is a common question we get from you. What should I focus on? Our refactory is so big, it has so many images in it. What should I focus on? So we're seeing this. We're coming to the running screen on runtime. We've seen this before. And we see that these container images are not scanned. And we want to configure it. We want to enable this scanning so we'll know what is their status. So we go to administration screen. We see that we have 3 clusters, but only 2 has security coverage. So we want to change that. We'll configure it, enable our different types of scanning. Remember, JFrog Advanced Security has different types of scanning. So from software composition analysis, contextual analysis, secrets detection. Let's enable all of them. Start with that. And from that moment, we will now save this config. And from that moment, these containers that have not been scanned will be scanned. The scan has succeeded, and we can see that we have 3 critical and applicable vulnerabilities that we need to care about. And remember, these are the vulnerabilities that we should mostly care about. They are critical, they are really critical, backed by JFrog research. They are applicable, backed by our contextual analysis, and they are running in production, baked by JFrog runtime security. So this is what we should focus on. This is where we should invest our time. But we've just started, right? We've just identified what we need to do. Now we actually have to fix the thing. And how do we do that in a fast way? And for that, we have a new announcement today. Maybe. Pretty nice. Okay, so just a quick demo on that. Let's go back to the screen. Yep. Okay, so what we're seeing here is, again, Visual Studio Code. We're seeing a Java project. That Java project is using Apache Struts, a very popular library, and it's using it in a way that makes it vulnerable. We'll see how. So what we're seeing here is a developer looking into the code and looking into understanding whether it has security vulnerabilities. So it goes to the JFrog VS Code extension. I can assure you it's not a malicious one. And we can see right away that we have a CV that is applicable, that is critical. JFrog gives us that it's critical as well, so we definitely should care about this vulnerability. And we want to look at contextual analysis, see why it happened. We can see it reference the vulnerable function. It also gives it user input, which can be controlled by attackers. So we want to see what we can do, how we can fix it. We can upgrade the direct dependency. We'll talk about that. We can also patch our code. And this is information that comes from the JFrog research team. We have this information on all critical vulnerabilities, and we give here information on how to fix the vulnerability. And we can see here there's a difference. 6.4.0 is a version that can fix this. 7 can also fix it with different conditions. We scroll down, we see that JFrog also gives us a way to fix our code in a way that will make us immune from such vulnerabilities in the future. So if there's a new vulnerability in Apache Struts, will be fixed. What we're doing here is we're fixing this through Copilot. And Copilot is starting to fix this based on the JFrog research data we just read. So it's starting, and it's telling us that it will try to do both fixes, both the dependency upgrade and the immunity from these types of vulnerabilities. Let's see if it succeeds. The first thing we're seeing here is it's starting to work not only with the prompt we gave it, but also with JFrog MCP server that connects it to curation. Why? Because when we upgrade a new package, we want to know that it's okay by curation policy. And it's not. 6.40 still has the vulnerability. If you want to use it, you need to change your code accordingly. But curation doesn't allow you to bring it in because it's still vulnerable. So what does Copilot do? He's trying to run it again with the 7 version. In this case, we can see that it has been approved by curation. It can pull it and fix the code. And this is happening so fast, I'm barely been able to explain it. But really what is happening here is that now we have the upgrade for the 7 package. But we also want to add protection against the path reversal. We also want to be able to protect ourselves from these type of vulnerabilities happening again in Apache Struts, so we have the fix. And this is exactly what is happening here. We're adding a new function that checks for safe access to files, and then we call it just before we use the information coming from external input. So we can see that this fix is happening. Copilot is building the application and compiling it again, and we can definitely see that it's been instructed by JFrog to scan the application again, and we're not seeing the vulnerability here on the top left again. We get a nice summary, a verbal summary that tells us that it fixed the vulnerability, and we can also see that it changed the upgrade. It verified it with JFrog curation, so it can be used. It added a path reversal protection. It had to change the version, the code, in order to use the 7 version, and it did that as well because there is a breaking change in 7, and we told him how to do it, or him or her, how to do it. Now, the amazing part of it is that this vulnerability has now been fixed. we can verify and attest to that because Copilot executed JFrog security scanning again, and the vulnerability disappeared. Contextual analysis gave us the clear. And now we are secured. So all of this agentic remediation allows us to fix very fast in a way that allows us to have also trust in this fix, because we have guardrails like curation that enables us to use just the packages the organization wants to use, and we can verify that the fix was actually successful. But most importantly, this is information that is coming from the JFrog research team and allowing Copilot, backed here by Claude Sonnet, to really fix this vulnerability with no issues, because we need this context, we need this data when we fix it, and Copilot alone, and you can try it on your own, will not be able to do that if not instructed by the JFrog research data and the JFrog MCP server. So this is now in GA and available. And to just recap what we've discussed today. We've discussed about protecting ourselves from new software supply chain attacks on malicious IDE extensions. We saw the release that we've done there to protect against those types of new attacks. We talked about prioritizing CVEs and what we should care about with whether they're really critical, whether they are exploitable, and whether they're running in production. Finally, we talked about our push for speed. We're using GenAI, the new, to protect us and fix the old. And this is a really important development that we're excited to share here. Now, our journey at JFrog Security have stretched towards protecting tens of thousands of developers in thousands of companies right now. This is from X-Ray to curation to JFrog Advanced Security to runtime. Many of you here have chosen to use these tools, and these numbers, I'm not going to repeat all of them, are coming from the field. These are real numbers of vulnerabilities, malicious campaigns, and packages that we were able to discover, secrets that are out there. And we're very proud of these numbers, and would be very happy to continue the conversation with you guys at the booth. And with that, I'll finish and let us all go to lunch.